Number 2, in lesson number 1, unit 6, Jada and Priya are trying to solve this equation. I'm going to write it over here. 2/3 plus x is equal to 4. And Jada says, I think we should multiply each side by 3/2 because that is the reciprocal of 2/3. Now, I would agree with Jada that 2/3 is the reciprocal of 3/2, but I would not agree that's what we should do in this particular problem. Because multiplication is not the inverse of addition, which is what we need here. We need the inverse of addition, or the additive inverse of 2/3, which Priya gives. Priya says, I think we should add negative 2/3. Well, if we do that, if we add negative 2/3 to both sides over here, and we add a negative 2/3 over here, what's going to happen is these are going to make 0 because they're additive inverses, and we will actually find the value of x when we do 4 plus a negative 2/3, which is 3 1/3. So that's going to work. Which person's strategy should we use? Priya, because adding negative 2/3 will make 2/3 equal 0. That's why we want to do that. Multiplying it by 3/2 would not do that. It would make it equal 1, and we wouldn't have x by itself. Write an equation that can be solved using the other person's strategy. Ooh. So this is a challenge, a way to think about Jada's strategy to make it work. Well, since multiplying by the reciprocal is the inverse of multiplying by the original number, we could just take the original number, which in this case is 3/2, and use that as a coefficient to a problem. And we can just make up any number on the other side. Let's just say that the other side is 6. And we did say we had to solve it. It just says that can be solved. This could be solved by doing what Jada wanted to do. If we multiplied both sides by 2/3, it would eliminate the 3/2 because that's the opposite of multiplying by 3/2. That is the inverse of it. The multiplicative inverse is multiplying by the reciprocal. So that was good. So let's jump down here to some missing operations. What could we throw in here to make this work? All right. If I'm on the number line at 48 and I want to end up at -6, there's no way I can add or subtract because it's too far away. So it's either got to be division or multiplication. Multiplication would make me grow. I need it to shrink, so this one has to be division. All right, let's go to the next one. -40 and 8. Once again, too far away for an answer to be added or subtracted. So this has to be multiplication or division, and it's shrinking with whole numbers, so it's got to be division. This one right here, if I multiply, I get 24. If I divide, I get 6. So that rules those out. If I add, I'd get positive 10. So this has got to be subtraction. If you subtract a -2, it's just the same as adding 2 because add the opposite rule. A little review of what some of you guys stink at a little bit. 18 and do something with it with a -12 to get 6. Division, multiplication out the window. If I add, it would go down 12, so that's what I want to happen. I want to add here. If I would have subtracted, it would have gone up 12 to 30. The next one is something with 18 and -20 to get -2. Well, if I subtract, it would actually add the opposite and go up. If I add, it would go down past 0 and get back to -2, so that's what I want to do here. I want to add. And the very last one, what would I do with these two numbers to get -11? If I add or subtract, I'm not going to get anywhere near this, so this has got to be either divide or multiply. And if I multiply by a number that's less than 1, it shrinks my number. If I divide by a number less than 1, it actually grows my original number. So multiplication is the choice here. The first time that we've multiplied in all these answers. So there's number 3.